its main intention is and main aim of it is to store the large amount of the data efficiently, and it's also process the data efficiently. One second guys, let me connect my laptop to the charging. I think it's trying to 9% now. I didn't see before. Okay, Hadoop is a Java-based framework which is designed or developed for to store a large amount of the data. Not only store, manage, and process the large amount of the data in efficient manner. So then, how it will solve the problems which we have seen last class? How will it solve the problems which we have seen last?
Using HDFS and MapReduce.
Yes. So it has a beautiful components called. It has a two beautiful components. One is a HDFS, another one is a MapReduce. Let's try to look at them. Hadoop come up with two beautiful components, or HDFS. HDFS stands for Hadoop Distributed File System. Hadoop Distributed File System. Other one is MapReduce. Map and reduce, actually it is. We'll see what is a MapReduce. Okay, so why it is a HDFS, why it is not a DFS? We're going to discuss that. Okay, so HDFS is a Hadoop distributed file system, which is a virtual layer on top of a local file system. So before that, let's try to understand what is a local file system. Local file system.
Somewhat like the OS, or like Windows, Linux, or
yeah, yes, it's a file system which is designed and which has been defined by our operating system. Something like, let's assume that a file system where the data will store. Why we call it a local? Because it is local to your operating system. It is local to your operating system. Your operating system will have a more command on this instead of user. More command on this. Like your operating system decides how to read the data, how to write the data. Your local file system also stores the data in the form of blocks. Your local file system also stores the data in the form of blocks, but here the block is 4 KB. Here the block is 4 KB. And also it is dedicated to single machine. It is dedicated to single machine. Doesn't mean that it will dedicate to only single machine. When you connect through a DFS, distributed file system, where when you share the all the machines memory, you can also look at as a multiple machines as single entry. We'll see that. But here in this case, your operating system will have a more control on it, saying that you have to read 4 KB blocks and you have to write the 4 KB blocks. Can we change these 4 KB blocks? Can I make it a 10 KB block? No, because this has been defined by your operating system. It is your operating system. While designing your operating system, they have defined this. The data has to be stored at 4 KB. Does it have a local file system? When I store the data, let's assume that I'm placing a data called my resume in my local file system. So will it automatically take multiple copies? No, it will not take multiple copies by default. It will not take multiple copies by default. It will not maintain the redundant copies by default. We have to specify explicitly, or we have to say multiple places. Are you able to follow, guys? So a local file system is a file system where it will store the data in the form of 4 KBs, and which is very much local to your operating system. Your operating system will have more control on this file system. More control in the sense it's already defined that how to store the data, how to process the data, and when I remove that, how to remove and where to keep the data. Okay. And what is a HDFS? HDFS is on HDFS is a virtual layer on top of the local file system. It can be a single machine or it can be multiple machine. It is a virtual layer on top of a local file system. It is a virtual layer on top of the local file system. Why I'm telling it's a virtual layer? That we cannot view. LFS, local file system. It is HDFS. It is HDFS. This virtual layer we will create by installing a Hadoop software. This HDFS layer we will create by installing a software. In this file system, because why it's called HDFS, because we are using a Hadoop software to create this file system. And that is the reason we'll call it a HDFS. And in this file system, we will be having a more control on it. We will be having more control on it. We in the sense, the developer. Let's say I want to specify, I don't want to go with the 4 KB. In the HDFS also the data will store in the form of blocks. In the HDFS also the data will store in the form of the blocks. Here the block size is 64 MB. Here the block is 64 MB. Why HDFS block is a bigger block? Why can't it be a smaller block? That point we'll talk. That point we'll talk in a few seconds. Here we can define the data. We have to store data in the form of blocks. The block has to be 64 MB, or it can be configurable. It can be changed. We can change it. It no need to be 64 MB. It can be 128 MB. It can be 512, or it can be 1 GB, or it can be 32, or it can be 10. We can change it. But while changing it, keep in mind that whatever the data we are storing in the form of blocks, the data has to be processed by a single mapper. It has to be processed by a single processor. It has to be processed by a single processor. Then if we change it to 1 GB, or if we change it to 2 GB, what will happen? The 1 GB data has to be processed by a single mapper. Single slot or single processor, I can say, which will take a huge amount of the time to process. That is the reason while changing it to the configuration, keep in mind that not only storing the data, after storing the data, sometime we may process it. So while if you are trying to modify any time, or if you're going to change the block size anytime, keep in mind that we'll be processing later point of time. According to that, we will change it. Okay, by default it's a 64 MB in a Hadoop 1. So in the Hadoop 2 is by default 128 is the default block size. Hadoop 2. Okay, let's assume that when I store the data in this local files in the HDFS file system, when I store the data in the HDFS file system, by default the data will be replicated. What is the replication? The replication is the data will store 3 different copies in 3 different locations. 3 different copies in 3 different locations. This HDFS has that facility. So our local file system doesn't have that facility. Clear, guys? Yeah.
Yes, sir.
Yeah. Let me go ahead and share a PPT. We'll just see what is a HDFS, and we'll continue with this. And we'll talk about the MapReduce more. A MapReduce is or an HDFS is meant for the storing the data, and MapReduce is meant for process the data, what are the data you have stored in the HDFS. So the MapReduce will talk more about when after finishing the HDFS we'll start talk about the MapReduce. Are you guys follow? Are you guys fine? Let me share. Let me present it. Okay. So let's try to read it. HDFS is a distributed file system that provides a high performance access to a data across the Hadoop cluster that is high fault tolerant. How it is high fault tolerant? Because it will store the data by default 3 copies. High fault tolerant and designed to be deployed with a low cost hardware. What is the low cost hardware? What is the low cost hardware? The low cost hardware is cheaper hardware, which is a commodity hardware. We'll call it as a commodity hardware. And let me show that where HDFS follows an architecture called HDFS follows an architecture HDFS follows an architecture that's called master-slave architecture. That's called master-slave architecture. What is a master-slave architecture? We're going to see now. Before going to try to see this master-slave architecture, let me explain a detail. Let me take you to a real-time scenario where we already were seeing this kind of master-slave architecture. I will show you that. I'll explain that what is master-slave architecture. Let's take an example. We are working for an organization. We are belong to a team. We are belong to a development team, or we are belong to a Hadoop team. Let's assume that. In the team, who is the master? In our team, who is the master? Let's assume that we all people are working for one project. We're all our team members. We have one team manager. Who is the master in our team? Our manager. Our manager is our master. What he will do? What he will do? Our master or lead or someone. Okay. What he will do? Will he take a development work? Will you do a development work? It's not everyone. Let's take in India team. Don't take the US team. The US team must even architect will do the development team. Development assignments. Okay. Let's take an Indian team manager. Indian in the India. Let's assume that in India. Master here, the manager who is meant for managing the team, not for the development. He will not take any development tasks. Most of the guys will not take the development tasks. Let's assume that. So few people are there who will work, but these are very out of 100, 10 people. So we'll not consider them for time being. Let's consider the 90 people. So 90% of the managers will not take the development work. They will take the management work. Why they will take the management work? Because they have their own specified roles for the management. Let's try to understand here. The master or team manager will not do actual work, will not process the actual work, or will not store the actual work, but he will make sure that someone will complete the task. Someone will complete the tasks. Who are they? Slaves. Who are they? We, team members. The team members are the actual members who will save, who will process, who will store the data, or who will process the data, or who will actually do the work in the real time. For team members, they will assign the task, the development task, and they will give the targets. We have to finish that work by the time. Who is the actual workhorses? The team members. And the team members will keep updating to the master saying that this is status of my ticket, or this is status of my development assignment work. How they will be intimating to the master? in the form of mails or in the form of meetings, stand-up meetings, or called as a standing meetings, or you call it as a emails. It will be happening frequently every day or twice in a day, not in a twice a day, twice in one time in a 2 days. It may be weekly or it can be daily. What your master will be doing, your master will be maintaining an Excel sheet saying that, okay, this guy, this is assignment is work assigned to him, and this is what the status. Along with that, he will also maintain the metadata about team members, like which team member is good at what. Let's say one team member is good at the coding part, I mean front end UI part, one team member is good at the back end, let's say DB side, one team member is good at the testing part. So he will be maintaining that all the details. Yeah, someone has some doubt, go ahead. Are you guys able to follow what is a master?
Yes, sir.
Yeah. Now let's try to see the same way our HDFS also follows the master slave architecture. Then it is formed with the architecture. The HDFS architecture is formed with the two nodes. What are they? What is a node? The node is a technical term. The node is a technical term used for a computer or a hardware which will participate in the network. Which participate in the network. It means that the hardware is connected in the network. The hardware is responding to you when you query, or when you ask for something. It is giving, or it is providing the service. That hardware will called as a node. Node is a technical term for a physical hardware which is persisting or which is participating in the network. And our HDFS architecture follows the two nodes. I mean, has been designed using the two nodes. One is a master node, and the other one is a slave node. Let's try to look at this. This is the master. These are the slaves. These are the slaves. The HDFS has named for the master is name node. It is a. It has named as a. It has been named as a name node. Sorry, Hamid, you are trying to talk something, but I'm not able to hear you.
Oh, sorry.
Okay, fine. And the other one is data node. Why it is called a data node? Why it is called a name node? I'm going to see. I mean, I'm going to explain. Here, the master is a name node. He is a master who is going to try to understand, guys. These are the roles and responsibilities of the name node I'm going to explain. He is a master. He's going to manage your cluster, your slaves, and is going to maintain a metadata about your slaves. Who are all they? Who are all belong to my team? Same way your name node is going to identify who are all belong to this cluster. What are their statuses? Whether they are working on something. I'm comparing with, again, normal real-time scenario. So whether they are working on any task, in this case, whether it's stored any data, if it's stored, where the data is stored, and what are they in the real time. If they are working on what task they are working, what are they, what is the status of it. All the details will be maintained by your name node. Your name node will not store any actual data. Try to remember this, guys. Your name node will not store any kind of data apart from metadata. What is metadata? a data about a data. Let me take an example for metadata. You have you have saved a movies under the D drive. Under the D drive, you have created a folder called entertainment. Under that, you have created a movies. Under that, you have categorized like Telugu movies, Hindi movies, Tamil movies, Malayalam and English movies. When you're trying to, what you'll say, if anyone asks you that where the movies are there, what you'll say, the movies are there under C drive, in entertainment, in the movies, and you can find under different categories. That information, that namespace is called metadata. A data about the data, more information about the data. What is that? Movies. What kind of movies? Different kind of movies. Where it is there? It is there in the under the entertainment in the D drive. This information is called a metadata. Is it clear, guys? That metadata will be maintained by your master. Like our manager, what our manager will maintain? The team members who are capable enough to handle what kind of issues, who are capable enough to handle what kind of development work, and where, what are they, what their statuses. That information will be maintained by your manager. The same way here, your name node will also maintain the same kind of information here. What is the data node, where it is deployed, and is there any process running on it? Is there any block is running on it? I mean, is there any data stored on it? And what is the current state of it? Whether it is alive or dead, that metadata information will be maintained by your name node. Your data, when it understand the name node, those are the roles and responsibilities of your name node. Let's try to understand the data nodes roles and responsibilities. The data nodes are the actual workhorses. That is why it's called as a data node, because we store the data into these machines. We'll store the data into these machines. Because of that, we call them as a data nodes. They will store the data in the form of blocks. They will store the data in the form of blocks, and the responsibility of them is they will be keep intimating, they will be keep talking to the name node saying that we are alive. They will keep sending a heartbeat. It's called a heartbeat. Actually, it is not a heartbeat. It is like a RPC call. It is a RPC call, remote processor call. We'll just say that I am alive. Every 3 seconds. Every 3 seconds, it will send a heartbeat. Your name node saying that I am alive. I am alive. And every 10 seconds, it will be sending the block report. Every 10 seconds, it will be sending the block report. The block report says that this is where the data is stored. This data is belong to some XYZ file. If any of the data node is not sending the heartbeat in 10 seconds, that your name node will treat it as a dead. Like any of the team member is absconded for 10 days or 50, he is not reachable over a phone or a mail or nothing. There is no communication channel with the team member. What he will manage will do, he'll manage will inform to your HR saying that this guy is just absconded. They will treat it as that guy is almost absconded. The same way here, your data node is not responded in 3 seconds, 10 seconds to the name node, your name node will mark it as a dead. Your name node is marked as a dead. Okay, and these guys are actually stores the data, and these guys are actually process the data. These guys has to, if they want to store the data and if they want to process it, the instructions should be there from your manager. If your manager is not telling anything, the guys don't do anything. Let's assume that you take in a same example. Your manager is not assigned any work. The team members will not do any work. They will not take any work from the client directly. It has to come through a proper channel, a proper protocol. It has to follow a proper protocol, and the communication has to come from their manager. The same way, the communication has to come from your data nodes. If your data node says that, go ahead and store it, and your name node is, when your name node says that, hey, you can go ahead and store the data, then only your data nodes will store the data. then only your data nodes will store the data. Sorry guys. Okay. And there is a communication channel between the data node to data node. And why it is called as a name node? We have seen why it is called as a data node, then why it is called as a name node. It will maintain the namespaces. It will maintain the main namespaces. What we have explained in the example namespace, like where the movies are there in D drive, under the entertainment folder, under the movies, you can go with the different categories movies. It is maintaining the namespace. The same way, the same way, the same way your metadata, your name node also will maintaining the metadata namespace. It will maintain the namespace. The tree structure. Why this tree structure? Because how our local file system tree structure looks: root directory and slash share, if you want to share, and the slash data. I'm just saying, like C drive, share data, like that. It can be under the root. You can have a home. Under the home, you can have a user, like your name. Let me take any of the name, Irfan. Under the Irfan, you can have a movies or softwares. Under this, it will be having, right? It is a tree structure. The same way, your name node also maintain the tree name spaces in the form of tree structure. It will also maintain the state. What are the information it will maintain? It will maintain the information such a way that what are the data nodes are processing what data and where the data is stored, and also it will maintain whatever the data is stored, the data belongs to which file. It will maintain the file to block mapping. It will maintain the metadata. It will maintain the metadata, which is file to block mapping, block to data node mapping, block to data node mapping. What is the file to block? Let's assume that I have a file which is called Amazon. Let's assume that I have a file called Amazon.log. Amazon log. This file is, let's assume that 100 GB data. When I store this data into the cluster, it will be before going into cluster, what it will do? Your client will break it into pieces. The client will break it into pieces of 64 MB, whatever your configuration, depends on the configuration. Let's assume that 64 MB in our case. This 100 GB will be broken into 64 MB pieces, and it will be storing in the blocks here. And it will be storing the smaller blocks, like all 100 GB will be broken into 64 MB chunks. 64 MB chunks, like it will be breaking like this, smaller chunks. After chunking this data, what it will do? These blocks will be storing in this, not the whole file. So let's assume that this chunk is 1 GB. Let's assume that this whole data is 1 GB. You will get 1 GB means if you 64 MB, how many blocks will come? How many chunks will come? 1 GB means 1024 by 64 into equal to 16 blocks. It will come. It will come close to 16 blocks. If it is 16 blocks, let's assume that B1 will be stored here, B2 will store here, and so on, B3 and so on. In the cluster, it will store B16. And also each block, each chunk will be replicated thrice by default. Each chunk will be stored thrice, three different machines. It will store 3 different machines. And these blocks are storing in different machines, right? So these blocks belongs to some file. What file it is? That's called file to block mapping. Let's see here. This Amazon has been split into 16 blocks, like B1, B2 and so on, B16. And each block is B1 stored in 3 machines, right? Let's assume that in this case DN5, DN3, DN1 or DN4. And block 2, again, block 2 is stored in some location. Block 3 is stored in different machines, right? So this is called file to block, and block to data node mapping will be maintained by your name node. How it will maintain or where it will maintain, all those things we'll go ahead and see very soon. Is this clear, guys? Are you guys able to follow? Okay. And one more thing, let me bring it a small idea here. Even though these are the different machines, even though these are different machines, for the client, for the end user, it looks like a single machine. Why it looks like a single machine? Because it is a HDFS. Because it is a HDFS, which is a virtual layer. The virtual layer will be formed on the multiple machines, right? You can store any number of machines, but I know only this. I know only this HDFS. I am assuming that I'll be storing the data here. Even that is storing one machine, it is storing 100 machines, I don't mind. I know only one path. Let's assume that I want to store the data in the form in the HDFS. Let's assume that HDFS : and some IP address / data / input / Amazon. I don't mind under this IP address how many machines are there. It's not IP address, actually it's a local file system, it's HDFS. Under this HDFS how many machines are there, I don't mind. But at the end I'll be looking at, this is where my file is stored. This is where my file is stored. This is where my file is stored. For me it looks like a single entry or single machine. For me it looks like a single entry. I'm not storing a block is going to this machine. I didn't log in to this machine and store the block. I didn't log in to this machine. I didn't store. I didn't log into individual machines. I just gave in one entry. You take how many copies you want and where you want to store. You just go ahead and take it. That's not my headache. It's your headache, right? That is why I told it's a virtual layer on top of your local file system. Is this clear, guys? Any doubts still here? Any doubts? Okay. This is the architecture is followed by your HDFS. For master and slave, this is the architecture is followed by your HDFS. Then how it will solve the problems, the limitation which we have seen in the old approach, which we have come across the limitations in the old approach, how this will solve, how it will solve that approach. I mean those limitations. Before that, try to understand what is a HDFS in more detail. Okay. Yep. Guys, the thing is, what I follow, I will not show the PPTs. I will not show the slides, and I will not explain one by one. What I will do, first I will explain the concept. I'll make sure that I'll take the better examples and make sure that you'll understand. Once you guys are okay, then I'll go ahead and show the slides for more information. If I start sharing the slides start presenting the slides, people will be looking at the slides, and we'll start reading the slides. We obviously will do the same, everyone, even if me. Then if we start reading the slide, what the presenter is presenting, what he is explaining, we will miss some points. That is the reason I'll show the presentation after I complete my explanation. Then I will explain the slide as well. Here there are two benefits. The same thing will be covering twice, so you will get more information. Okay, let's go ahead with the slides. Before knowing the HDFS, try to understand what is the DFS. What is a distributed file system? what is the distributed file system, then we'll see the what is the HDFS. Already we have a distributed file system, right? So why again HDFS? When I have a HDFS, why should I go with the HDFS? Let's try to understand the difference between those two. Before that, let me explain you. If I have, what is a distributed file system? Before that, non-distributed file system. We'll see non-distributed file system. Non-distributed file system, it will maintain all the data will go to a single machine. Let's assume that I have a machine which has an IP as a 10.20.30.40, and where I'll store the data as only employee data. And I have one more machine, it's a non-DFS. And I have one more machine which is 11.21.31.41. It will store the students data. I have one more machine which is 12.22.32.42, where I'll store only salary information. Let's assume that you have one more machine which is 13.23.33.43, where I'll show only DPT department data. If you try to understand here, these are the independent single machines. Those are independent single machines, right? Those are independent single machines. If I want to look at the student data, I have to log into the machine which is 11, 21, 31, 41 machine. I have to look at the student data. If I want to process the employee data, I have to go to 10, 20, 30, 40 machine, which is an independent machine. I have to go that machine. The same like others as well. The data is complete data. The whole data is storing by single machine. Guys, the whole data will be storing by single machine. If the whole data has to be processed by it will be processed by a single machine. The whole data is being processed by a single machine, right? And also it is a sequential process. What is this? It is a sequential process. It's not a parallel process.
Step-by-step process.
Yes. If you want to process the employee data, I have to go to the employee machine, and the employee machine is a single machine, so single processor. Right? Understand what is the non-DFS?
Yes, sir.
And if employee machine is failed, do you have a recovery? If employee machine is failed, do you have a recovery? I don't have recovery because it is the whole data is stored in single machine. Right?
Yes, sir.
Let's see a DFS now. DFS is a multiple machines as is shown in the same way. Multiple machines are connected through internet. And all are belong to single IP. All are share the data. That's what I'm trying to show here. All are in, and it is a shared drive. Let's assume that is a public is a shared drive. It means the share to public. Under public, I have employee data and student data, and I have a salary. I have a I have a salary, I have a DPT. Single entry. Actually, DFS is a single entry. It means that multiple machines will be connected in the network. Multiple machines are connected in the network. This guy stores the EMP, this guy stores the student, and this guy stores the salary, and this guy stores the DPT. But all are connected internet. But when I want to store the data, I don't need to go each and every machine. It will be like, just see here, I'll be drawing one more different diagram. You'll be having a single entry, the shared memory. That is not shared memory, actually it is a shared entry. If I want to store the data, I'll say that, okay, go to this IP address /public/EMP. So I don't know, I don't worry where the data is getting shared, whether it's going to this machine, or it's going to this machine, or it's going to this machine, it's going to this machine. It completely depends on the how you configure. But here for me a single entry. For me it is a single entry, right, which is red color. What I will do, public/EMP. If I want to access EMP, I can access EMP because it is shared, a single entry. I don't need to specify the IP address. In the non-DFS, I have to specify if I want to talk to EMP data, I have to specify 10.20.30.40. something on /EMP. If I want to talk to student, 11.21.31.41. something, and I need to talk to specifically. But in the DFS, distributed file system, or the DFS can be called as a network file system as well. The network file system, I'll be having a single entry which is a shared drive, a shared path where I'll access the data or where I'll store the data, including the permissions. They'll give the permissions whether you can able to access or not. If you have authentications, and you can go ahead and access it, right? And this is the DFS. There are multiple machines will be there under the root, underneath or under the below layer, but for you it looks like a single layer. But what is the difference here? Here the whole data will be storing by single machine. Again here also the whole data will be storing the single machines. But the only difference is for end user it looks like a single entry, but at the bottom whole data is storing by single machine. And any one of the machine is failed, no, I don't have the recovery. Okay, if I want to process employee data, I have to log in. I have to say this single path, but the whole process will go in the single machine. The whole process will handle with a single machine. Right? This is the DFS. This is the DFS, or it is called a network file system also. It's called the network file system. If you want to process the salary, first of all, what I have to do? I have to directly go and process for salary. If I want to process the whole data, first I have to go and process employee, then I have to go on student, then salary, then department, one after one. It's a sequential process. Okay. Let's go ahead and see what is a DFS. A method of storing and accessing file based on a client-server architecture, which I have shown you multiple machines and one client. In the distributed file system, one or more central servers are stored the files that can be accessed with a proper authentication rights with a number of remote clients in the network. What we have seen before, there will be multiple machines will be there. Multiple machines will be there, and the data will be stored in the multiple machines. So the employee data will go in employee file, employee machine. Student data will go in student machine. Salary will go salary machine. Department will go in this department machine. But if you want to access it, you should have a proper authentication, right? And all will be stored in the single machine. You should have a proper authentication. But data potentially stored on another machine. It means that at a single machine, the whole data will be stored in the single machines. The read and writes must go through a network. And for example, a network file system by Microsoft. Even when files are stored in multiple computers, the DFS can process and display the files as if they are stored on one computer. Even though multiple computers are there, the distributed file system, which is the layer, the red mark which I have shown, it will display like a single entry. It will look like a single machine, but actually it is not a single machine, it's back into multiple machines. In NFS, all data belong to an entity, which is entity means files or set of files to stored on the single machine, and thus they require a dedicated hardware. The drawback is, we are going to see the drawbacks of it. Are you guys clear about the DFS? Guys, it is one of the interview question. What is the difference between the DFS and HDFS? Okay, let's go back to the differences. How many it seems that you have some doubts?
No, sir. All clear.
Okay, fine. So this is the before DFS, what I have shown in the before whatever I have explained. Without DFS, you'll be having independent hardware and independent IP addresses. When you want to access them, you need to log into the specific IP address and you have to get the data. But when of the DFS, you'll be having multiple machines which are connected. See here, it's a single entry DFS and public. It's a single entry, public. You'll be accessing all this public folder and you'll be storing the data or you'll be accessing the data. It will be having a global access name or global namespace. When it comes to your local namespace, for each and every has their own namespace. But when it comes to the DFS, you'll be having a global namespace which is www.this.com, and the public is a single access, the shared drive or I can say shared path where you can access the employee and salaries. Okay. And what is the drawback? Suppose if you want to process a huge amount of the data which is there in the single machine's employee, and let's assume that the data is 1 TB and your data transfer rate is a 100 Mbps and number of channels at a time, core, the processor, 4 core processor, and how much time it will take? We'll see that, how much time it will take. The same data is stored in multiple machines, not in the single machine. The same data has been, the 1 TB data has been stored in the 10 machines, like 100 GB, 100 GB, 100 GB, 100 GB, and those also have the same configurations, like speed is 100 Mbps and 4 core for one machine. While you calculate data by speed, what is the data in MBs? This is 1 TB in MB, and 4 core into 100 MB, that 100 Mbps, right? I need to convert into seconds, into 60. It has taken me for one machine to process 1 TB data 43 seconds. Let's assume that 1 hour. When I go with the 10 machines, the same data, the parallelly processed, I reached in the 10 seconds, I mean 4 minutes. Why? Because the same data has been processed by multiple machines and multiple parallelly. The best example is that, let's assume that I have 10 apples in the 10 boxes. I asked one person to collect all the apples. What he will do? He will just collect one after one, one after one, one after one. Let's assume that I have 10 people and 10 boxes. I assign each box to each person. I ask to collect the apples. The 10 people will collect in single attempt. So I'll reducing. I mean, I'm getting in less time. People are collecting apples in a single attempt and we're saving the time. The same way here. How the data will be processed in the DFS? There will be master and slave, and data will be stored in the. Let's assume that this is employee data and this is student data. This is salary data somewhere else. If you want to access the data, you should have a storage network area. That's called SAN, storage network area. That guy will talk to one employee guy and get the data. If guy will talk to the students and will get the data. If guy talk to the salaries and department, will get the data. It's a sequential process. That is a sequential process in a DFS. Then what is a HDFS? Then what is a HDFS? Then we have seen the DFS. Then what is a HDFS? 1 second, guys. I think it's a 6. Yeah, it is 6 in India. We have started 1 hour before, and there is I mean, I have another other class, so we'll stop here. We'll continue tomorrow from what is a HDFS. Is this fine, guys?
Yes, sir.
Okay. Okay. A small request, guys. I know that you guys are recording the session, and whoever recorded the session, could you please share with me? I forgot to start today. I mean, I realized that I'm not recording, but I didn't do that. Okay. So could you please share with someone? Who will share?
I am not doing recording, sir.
Okay. SRIT, I think those are all they will be doing. Suraj, are you doing the recording?
Suraj says no, sir.
Is it? Is it no? Then who recorded it? Nikhil or Irfan?
No, sir. Even I didn't record.
Okay. I thought the student someone will be recording it. Actually, I used to do that. I will do that normally.
I'm actually just taking notes. So
Okay. Fine. I'll talk to the our organizer. I'll talk to our organizer. Our organizer might be recording it. Ideally, every day I will do it.
Irfan is asking how to share.
Okay, I think Irfan is recorded. Create on Drive. Create one Google Drive, and you just share to everyone, so they can share your email address to you. My email ID I'm sharing here. I have shared my email. Sorry. Okay. And to okay, this is my email ID. Yeah. So you can share to. You can create one directory. You can give access to them. Whoever can share. Tomorrow onwards, I'll make sure that guys, I will record it. Tomorrow onwards, I will make sure that I will record it. Okay. And I'll be creating the drive for us, and I'll be storing the not only the videos, whatever the content we have covered, and I'll be putting that content into the drive.
Yes, sir.
And
It will be
everyone,
helpful for him.
yes, yes, I will do that. I will do that. That is a
Thank you.
the regular practice. I used to do that. That's a regular practice. Today I just somehow forgot, and anyway, someone will be doing that.
Yes,
They
sir.
will share it. Okay.
For every
Please,
day
guys.
class will be like for 1 hour, so daily 6:30 to 7:30. From 5 to 6.
Yes, daily 1 hour. So, is there any concern, guys?
No, no problem, sir.
Every day the class will be 1 hour.
Okay, sir.
Okay. Irfan, please share with us. Okay. So, thank you, guys. Thanks for your time. So,
thank you, sir.
that's all. That's it for today.
Thank you, sir.
Thank you.
क्या है नहीं इरफान रिकॉर्ड कर अच्छा इसमें रिकॉर्ड कैसा करते यार मैं कोई नहीं आया बोलो बोलो मैं क्या होगा तो रिकॉर्डिंग का समझ में नहीं आ रहा इसमें if you don't want to record mute yourself and don't share your screen हाँ नहीं गो टू मीटिंग से करते बहुत दिन रिकॉर्डिंग है नहीं साहब मेरे दोस्त करे थे if you don't want to record mute yourself
Sorry, guys, I didn't get the conversation. What you guys are having?
हाँ चलो
Hello. Hello.